Good morning, students. Jai Swaminarayan. Wishing you all a prosperous Deepavali and you can say a fantastic new year ahead. Now we are within a range of starting regular sessions in the school. So students, let us hope for the best, and you can say on this very auspicious day we start chapter number 4, measure of dispersion. Now students, in chapter number 3 we have studied measures of central tendency. The fundamental measures of central tendency were mean denoted by x bar, median denoted by m, and students mode which is denoted by m0. As such, these are the basic fundamental measures of central tendency, students, which we have already studied in chapter number 3, and few positional measures such as quartiles, deciles and percentiles, students, we have studied. So recall, students, in chapter number 3 we have studied all the basic measures of central tendency, and students, those measures were mean denoted by x bar, median denoted as m, and mode which was denoted by m0 plus, students, all the basic positional averages such as quartiles, deciles and percentiles. Now students, in this chapter we are going to study measures of dispersion. So I write here, you can say plural, measures of dispersion. Now by this time all of you are aware of, you can say, ungrouped data and group data. Let us revise. What is ungrouped data? The data which is in, you can say, raw form, which is neither classified nor grouped. The data which is in raw form, which is neither classified nor grouped, is called ungrouped data. Or in simpler terms, we were defining, students, ungrouped data as the data without frequency. And group data, the data which is classified, which is tabulated, which is grouped in the form of classes and represented along with frequency, students, is called group data. These, students, we have already studied. So as a basic revision, we again revise that in statistics the data is totally classified into two broad categories, and the first category is ungrouped data, and students, the second category is group data. In very simpler terms, data without frequency is ungrouped data, and students, the data with frequency is group data. So I start with ungrouped data observations xi, which I write as 1, 2, 3, and if I total this, then summation xi is 6. Now students, if I operate mean, x bar is equal to summation xi upon n, 6 divided by 3, and that is 2. So I am starting with some basic concept, and then we are going with the definition of measure of dispersion. So I have written some ungrouped data observations, and the simplest ungrouped data observations are, students, 1, 2 and 3. If I total, I get 6, and if I operate mean, then students, I get 2. Now I am operating xi minus x bar, 1 minus 2, minus 1, 2 minus 2, 0, 3 minus 2, 1. This total is 0. Now students, I operate mod xi minus x bar. Then this is 1, this is 0, and this is 1. So this total is plus 2. Now students, pay attention. What is dispersion? A measure of dispersion indicates how far the given observations are from the measure of central tendency. A measure of dispersion indicates how far the given observations are from the measure of central tendency. So I can say dispersion of ungrouped data observation 1 from mean 2 is 1. Dispersion of 2 from mean 2 is 0. And dispersion of 3 from mean 2 is 1. So a measure of dispersion, students, indicates how far the given observations are from the measure of central tendency. How far means distance, and distance can never be negative. So I say once again, dispersion of 1 from mean 2 is plus 1. Dispersion of 2 from mean 2 is 0. Dispersion of 3 from mean 2 is 1. So this is, students, the definition of measure of dispersion, which justifies the title of chapter number 4. So once again, a measure of dispersion indicates how far the given observations are from the measure of central tendency. So dispersion is always discussed with respect to, students, the measure of central tendency. So before studying dispersion, we must be very clear with the fundamental aspect of measure of this central tendency. Now students, desirable characteristics of a measure of dispersion, which is very similar to ideal characteristics of a measure of dispersion. The definition, the first characteristic, students, the definition of a measure of dispersion must be simple, clear and precise. Then you can say it should be simple to understand and easy to compute. The same characteristics, students, we had for the fundamental measure of central tendency in terms of characteristics. So desirable characteristics of a measure of dispersion are very similar. Then it should be based, the calculation of a measure of dispersion, students, must be based on all the observation. We must use all the observation. Then it should be suitable for further algebraic manipulation. Means when I am using it in some reference, I can manipulate it, or I can round it off. Manipulation means round it off. It must be a stable measure, that is sample of same size selected from a population, and if I calculate those measures for samples of same size, the value must be almost same, and it should not be affected by unduly the large and the small observations of the given data. Students, if you refer this theory of chapter 3, this will almost be same. The 6 characteristics, students, are almost same. So let us revise, students, once again. All of you please pay attention. Desirable or I can say ideal characteristics of a measure of dispersion. It must be simple, clear and precise in terms of definition. the definition must be unambiguous. Unambiguous means students without any doubts or confusion. It should be easy to compute and simple to understand. Third, all the observations must be used in the calculation of a measure of dispersion. Fourth, it must be suitable for algebraic manipulations. Fifth, very important, it must be a stable measure. Say I divide your class of 60 students into samples of 3 each. So I will have 20 samples. And for each sample, when I compute the measure of dispersion, the measure must have same answer. And last but not the least, it must not be unduly affected by the smallest and the largest observation students of the given data. So students, this is what we have already discussed. Once again, to summarize, what is a measure of dispersion? A measure of dispersion indicates how far the given observations are from the measures of central tendency. I have taken here mean. Even I can take xi minus median, and even students I can take xi minus mode. So it is not necessary that dispersion is always studied with respect to mean. It can be studied with respect to median as well as mode. So this is what students we have discussed, and its desirable ideal characteristics. Now students, measure of dispersion are basically of two types. Measures of dispersion, students, are basically of two types. First is absolute measure, and second is relative measures. So as such, measures of dispersion are classified into two broad categories: absolute measures and relative measures. Students, theories are very important. Do not bother about deleted syllabus or this or that. The main part of this chapter is to understand, and you can say go for basics. So students, we should not only be concentrating on what is deleted, what is kept, and what is not to be studied, and what is to be studied. Students, your main focus must be on fundamentals rather than only what is deleted, what is kept, and what is not kept, what is left. You should not at all be worried about. Okay. So students, measures of dispersion are divided into two broad categories. The first is absolute measures and the second is relative measure. Now students, we have already studied range in chapter 2. Yes or no? Of course yes, students. We have already studied range in chapter 2. So, suppose I am discussing weight, and the highest weight is 60 kg, and say the lowest weight is 50 kg, then range is nothing but except minus XL, 60 minus 50, so I will get this as 10 kg. The range, all of you know. The definition of range is the difference between the highest and lowest observation of given data. Now students, you might be wondering why I am discussing range. Range is one of the measure of dispersion. But now I want to define absolute measure of dispersion. A measure of dispersion which is expressed in the same unit as that of given observation. Check here. My given observations are weight, and I have taken the unit of weight as kilogram. Then range I am getting 10 kilometer. So the measure means the unit of observation and the unit of range is same. So what is the definition of absolute measure of dispersion? I can say a measure of dispersion which is expressed in the same unit as that of given observations is called, students, an absolute measure of dispersion. I have taken an example of range. Observations are given in kilogram and range also, students, I have written in kilogram. So unit of observation and unit of range is same. Therefore range is called an absolute measure of dispersion. So what is the definition of an absolute measure of dispersion? A measure of dispersion which is expressed in the same unit as that of given observation, students, is called an absolute measure of dispersion. Then what is relative measure of dispersion? A measure of dispersion independent of the units of the given observation is called a relative measure of dispersion. A relative measure, students, is always expressed as ratio. And if we have studied ratio and proportion perfectly, you know a ratio does not have any unit. Suppose I take ratio of 60 kg and 50 kg, kg and kg gets cancelled. So, a measure of dispersion independent of or free of the units, a measure of dispersion independent of units is called a relative measure of dispersion. So, as said, we have two types of measures of dispersion. One is absolute measure, students, and other is relative measure. A measure of dispersion free from units of measurement is called relative measure, and a measure of dispersion which is expressed in the same unit as that of given observation is called an absolute measure of dispersion. This, students, we have to perfectly understand. So, theories are very important, students. This chapter is such a chapter which is used in all the competitive exams like CA, CS, you can say MBA, MCA entrance exam. The topic of dispersion is always covered, students, in this type of competitive examinations. On this very auspicious day, students, we go for all the fundamentals. Now, what are absolute measures of dispersion? Absolute measures of dispersion. The first and the foremost is range, and all of you know that range is denoted by capital R. Second is based on quartile, and it is termed as quartile deviation and denoted as Q suffix T. The third is mean deviation, or even it is called average deviation, denoted as delta x bar. And the fourth and the last one, very important one, is called standard deviation, denoted as small s. So these are, students, the following absolute measures of dispersion. Students, these measures are absolute measures of dispersion. The first is range, denoted as R. Second, quartile deviation, denoted as QD. Quartiles are Q1, Q2, and Q3. All of you know. If we revise the definition of quartiles, quartiles divides the data arranged in ascending order into 4 equal parts, and the three quartiles. Find that Q1, Q2 and Q3. So students, these are the four basic absolute measures of dispersion. First is range, denoted by capital R. Second is quartile deviation, denoted by QD. Third is mean or average deviation, denoted as delta x bar. And fourth is standard deviation. And for your knowledge, the most important measure of dispersion is standard deviation. And again, this is affiliated to our one and only one, the most famous and fantastic personality in statistics, and that personality all of you know is definitely our Mr. Carl Pearson. So, students, this is the highlight of the chapter. We are going to find, calculate, study merits, demerits and fundamentals of these four measures, which are absolute measures of dispersion. So now, students, we are going to discuss the first measure, and that measure is nothing but range. I hope all of you know the definition of the range, and all of you have already studied, and we have used range at least 10 times in chapter number 2. So what is range, students? All of you know the difference between the highest observation and lowest observation of the given data is called range of the data, denoted by capital R. Range of the data, students, is denoted by capital R. XH, H suffix denotes the highest observation in terms of numerical value, and XL, L suffix denotes the lowest observation in terms of numerical value. So in short, students, all of you know what is range. So we have again revised the difference between the highest observation and the lowest observation of the given data, students, is called range of the data. Range is denoted by R, and the formula to find range is R is equal to XH minus XL. The next is relative range. Or I say coefficient of range. The next concept is the relative range or coefficient of range. The ratio of range upon XH plus XL, this ratio is called relative range. I am writing in short IR, but this is not the symbol. So what is relative range, or students, what is coefficient of range? The ratio of range divided by XH plus XL is called relative range, or students, coefficient of range. So the first measure is range. The formula, and mind you, relative range or coefficient of range is you can say is a relative measure. We have already written the word relative. So relative measures are independent or free from units of measurement. Whatever units are given for the given observation, relative range or coefficient of range does not have any unit. So the first measure is range. The formula to find range is XH minus XL, and relative range or coefficient of range as formula range divided by XH plus XL. Mind you, in chapter number 3, we have written formulas of every measure of central tendency into two broad categories. One is for ungrouped data students and another is for group data. Here, the formula is same for ungrouped data as well as group data. So I am not dividing or I am not categorizing students the formulas. Whenever I am finding range, whether it is students ungrouped data or students it is group data, the formula remains the same. The concept also remains the same. Okay students, so now on this day, on this auspicious day, we are going to start as well as complete exercise 4.1, and I am hoping that you will enjoy the 4 sums given in exercise 4.1, and these are the very easy sums. Range and relative range, this type of sums are the easiest concept of your chapter number 4. So let us do the first sum. The following data refers to the height in centimeter of 10 students of a class. Find range and coefficient of range of height of the students. So whenever you refer the question and you collect the data, remember which measures are asked. Always you will be asked one absolute measure and one relative measure. Relative measures will be all ratios and coefficients which are independent of units of measurement. So seeing the highest and the lowest observation students, the highest observation is 185 centimeter and the lowest observation is 145 centimeter. So we start with exercise 4.1. Answer 1. From given data, of course, XH is 185 centimeter and XL is 145 centimeter. So, your first step in the algorithm to do the sum. Students, the first step in the algorithm to do the sum is to locate highest and lowest observation. So we find range R is equal to XH minus XL. 185 minus 145, which is nothing but 40 centimeter. So check the unit of given observation, which is height, is in centimeter, and the unit of range, students, is also centimeter. So definitely this is absolute measure. Then coefficient of range or relative range is range divided by XH plus XL. So 40 divided by 185 plus 145. This is also in centimeter. This is also in centimeter. So this is 40 divided by 330. Centimeter gets cancelled. So 4 divided by 33, so approximately 0.12. So this does not have any unit. So this is called a relative measure of dispersion. So in the sums of range, students, we have to only locate the highest and the lowest observations from the given data. Okay students, now let us do sum number 2. Let us check what are the highest and lowest observations in the given data. A bus company has 77 buses for traveling in the city. The information of number of passengers in the bus on a particular day at a particular time is given below. Find range and coefficient of range. Mind you, this is group data because frequency is given. But the formula of range is same for group data as well as data. Now, we are not at all concerned with frequencies. The main part of the sum is to locate highest observation and you can say lowest observation. Xi is number of passengers and Fi is number of buses. So XH is 37 and XL is 2. And this number of passengers. They have told find range and coefficient of range for number of passengers. So number of passengers will be Xi. So this is 37 minus 2, which is 35 passengers. And relative range will be 35 passengers divided by 37 plus 2. This may mean passengers gets cancelled, so it is 35 upon 39. And if I find it is 0.90 approximately. So range is absolute measure and students coefficient of range is a relative measure. That's all, students. Now let us do the third sum. Very simple. The sums are, students, very simple. Now using the following frequency distribution of marks of students of a school, find range and relative range of marks. So marks will be Xi. Now this is a group data as well as continuous frequency distribution as well as exclusive. Lowest marks are, you can say 20 and highest marks are 80. So range of the marks will be 80 minus 20 and that is 60 marks. Relative range will be 60 marks divided by 100 marks. So definitely this is 0.600. That's so easy, students, so easy, very easy to understand and do the sum. So I leave for you, students, to do sum number 4. Here we conclude the lecture. Thank you, students, and once again all the best.